Here we have a triangle ABC. We know an angle C of 52 degrees. We also have a point D right in the middle of the side AB. Point E is somewhere on the side BC, and point F halfway between E and C. We know also a couple angles here. We know angle between AE and AC of 24 degrees, and we know the angle between AB and AE, which is 28 degrees. And we asked to find this angle X here, or angle BDF. So first of all, let's do the obvious thing. We have angles 28 and 24 degrees. We add them up, and we're going to get that angle A is 52 degrees, same as angle C. One thing we can do, we can find angle B. And also, since angle A and angle C are both congruent, it means that we're dealing with an isosceles triangle. And AB equals to BC. Now let's consider the smaller triangle, BAE. We know two angles of that triangle, angle of 76 degrees and angle of 28 degrees. We can calculate the third angle, which is going to be 76 degrees. And that means that AB equals to AE, and we have an isosceles triangle. Every time when I see midpoints somewhere, points that split some sides on some segments into halves, I always think about parallel lines. I'm thinking about midlines of triangles and things like that. So in this case, what we're going to do, we're going to get the point G in the middle of the side AC, and we're going to connect D and G. DG is what's called midline of a triangle, and it has interesting properties. First of all, DG is parallel to the side of a triangle BC, and also the length of DG is half of the length of BC. But we know that BC equals to AB, and DG is half of AB. It means that DG equals to AD and BD. And let's make them brown. Now if you look at the triangle ADG, it's an isosceles triangle, so angles at the base should be equal to each other. One angle is 52 degrees, the other angle should be also 52 degrees, and the third angle we can quickly calculate will be 76 degrees. Next thing we're going to do, we're going to connect point G and F. And now if you look at the triangle AEC, we find that FG is actually midline of this triangle, and therefore it should be half the side AE and also parallel to it. But we remember that AE is the same as AB, and therefore FG should be equal to DG. As I said, FG is a midline of the triangle AC, so it has to be parallel to AE. And now notice that the quadrilateral HEFG, that quadrilateral is actually a parallelogram because GF is parallel to HE, EF is parallel to GH. And in parallelogram, opposite sides are congruent, so GH equals to EF. And the next thing we're going to do, we're going to look at this yellow and green triangles. These triangles are congruent to each other by two sides and angle between them. So the side is AG and GC, and the other side is HG and FC. And the angle between them is 52 degrees. In congruent triangles, like respective sides and angles are congruent, and therefore this angle right here should be equal to the angle 24 degrees, which is here. And now if you look at this point G, or angle AGC, which is 180 degrees, it consists of angle of 52 degrees, 24 degrees, and angle 104 degrees right here. The next thing, we're going to look at this gray triangle here. It's an isosceles triangle. DG equals to GF. And in isosceles triangles, angles at the base should be congruent. We know the third angle of 104 degrees. It's easy to calculate that the other two angles should be 38 degrees. And now the final step, if you look right here, this angle ADB of 180 degrees, it consists of angle X we're interested in, angle of 38 degrees, and angle of 76 degrees. And that makes angle X equals to 66 degrees. So this is one of the many ways you can solve this problem. You can try to find some other ways, and I'll leave some comments here. I just want to show you some other methods we can use. And I'm going to go very quickly without actually going into too many details. One other way we can work this problem out is to look at this yellow quadrilateral, which is actually an isosceles trapezoid. And now if we connect B and G, which is the diagonal of the trapezoid, it's also a side bisector of the big triangle ABC, which is an isosceles triangle. And therefore, this side bisector is also in altitude. And now, from the fact that we're having an isosceles trapezoid, which is symmetric, we find this angle X, angle BDF, should be congruent to angle BGF, or angle right here. And now we see that X plus 24 give us 90 degrees, and therefore X should be 66 degrees. That's another way to find the angle, but really there are very, very many other ways to do it. And you're welcome to explore them.